Hello everyone, welcome back. And today we're gonna keep going with the derivative. Um, some other rules are gonna be very important as well. Sometimes we're gonna learn from the circular functions. And first thing first, we're gonna try to do with the derivative with circular functions. And when y equal to sine k theta. So as we know, the key is our real number, and the theta is our angles, and some special angle gonna be mentioned this time as well. Just make sure you guys understand and how we're gonna go through. Okay. Let's start with a very simple one. I want you guys to write down the rule, which is f theta equal to sine theta, your f dash theta equal to cosine theta. So which is your derivative sine is equal to cosine. Yeah, and once you know if you're getting the numbers inside the brackets, which has become the key theta, you can leave the k outside the bracket and the cosine k theta. So those two rules are gonna be during this time. And the opposite way, if you had a cosine k theta, the derivative of the theta will be negative k sine k theta. So make sure that's a negative in front. Okay, so next we're gonna be the new function. It's called the secant. And we say sec. So it says sec theta gonna be equal to 1 over cosine theta. And then, which means if we have your tan k theta is a function of the theta, then your derivative equal to k sec square and k theta. Please write this one as well in your reference book. Yeah, perfect. And once you finish, and we actually can start some questions. Um, so now let me introduce some questions like the square outside the sine, and that's the first one, the most actually obvious one is sine square to theta. So the first question is, I'm gonna using some rule which is we learned from this chain rule to do this question. And first thing, I will let y equal to sine 2 square, which is 2 theta, and u equal to 2 theta, actually sine theta. Sine 2 theta, let's let equal to u. So then y equal to u squared. And what happened to du d theta equals? So that equal to 2 cos 2 theta. And your dy du equal to 2u. So now your dy d theta, make sure that's a theta, not x, equal to du d theta times dy du. And that equal to u squared, 2u times 2 cos 2 theta. And u equal to sine 2 theta, so that actually equal to 2 sine 2 theta times 2 cos 2 theta. And that equal to 4 sine 2 theta times cos 2 theta. And that is your answer. Hopefully make sure you guys simplify in the end, especially you have two twos. And please make sure you're gonna simplify. Alright, let's start example 2. So this one, still we're gonna start with some chain rule. And we're gonna start with chain rule. Let u equal to cos 4 theta plus 1. du d theta equal to 4, negative 4 sine 4 theta plus 1. And then y equal to u cubed. dy du equal to 3u squared. And now dy dx equal to, dy d theta equal to dy du du d theta. So that equal to the negative 4 sine 4 theta plus 1 times 3u squared. And that equal to negative 12, because we can change that one to multiply each other. Sine 4 theta plus 1 times, what's a u? That's a cosine square 4 theta plus 1. And that is your final answer. Hopefully that makes sense. And then next one I'm gonna do with some like tangent, which is the kind of important as well. So we're gonna using the chain rule again. So we can say chain rule actually very important. So let u equal to 3 theta plus 1. And because that's a 10, there's only one 10, so that's why I'm using the inside rules, which is we don't have to let the, for example, before the question, I let cosine 4 theta plus 1. So now because that's only one tangent, so we don't have to do that. So yeah, du d theta equal to 6 theta. And then y equal to 10 u. So dy du equal to, we're using the previous knowledge, which is in here, k sec square k theta. So that means in here become to sec square u. And then dy d theta equal to dy du times du d theta. And that actually equal to 6 theta times sec square u equal to 6 theta times sec square 3 theta square plus 1. That's it. Hopefully that understand how we do this question. Alright, the last examples for today. Hopefully you guys learned already. And let's have a read about this question. Find the y coordinates and the gradient of the tangent at a point on the following curves corresponding to the given values of the theta. So first thing, gradient of tangent. If you see this one, what are we going to do? We've been mentioning that one in the previous knowledge as well, which is, we call that is a derivative. So once you know this question, and we're going to do the derivative. So let's have a look. So for this one, because y equal to cosine theta, so the dy d theta equal to negative sine theta. So when theta equal to pi on 4, your y equal to, we need to find the points, right? And also we're going to find the value of this theta. So which is y equal to cos pi on 4, that actually equal to negative square root of 2 on 2. So, and then your dy d theta, when theta equal to pi on 4, equal to negative sine pi on 4. That equal to, which is on the fourth quadrant, and then that's a negative. So that means it's a negative 1 over root 2, or we can say negative root 2 over 2. Yeah. So the gradient at point pi on 4 and root 2 on 2 is negative 1 over root 2 or negative root 2 on 2. Perfect. And the same idea is, let's go with when theta equal to pi on 2. Y equal to cosine pi on 2. That equal to 0. Because when the 90 degrees cosine equal to 0, hopefully that knowledge from the circle function from last year, which is from year 11, so this year from year 11. And then the dy d theta equal to negative sine pi on 2. That equal to the negative 1. So the gradient at pi on 2, 0 is negative 1. That's it. That's all you need. Thanks for listening, and see you guys in next chapter.